Hi, everyone. Thank you for the invitation to speak here. I want to talk today about this year in the Ceph community. We're celebrating the 20th year anniversary of when the project started. And I want to talk to you about why I believe Ceph is still the best choice for modern data storage. So before I begin, here's the proof that it's our 20th anniversary. The first commit, this is a screenshot of the 20th of the first commit. We're celebrating the 20 years of awesome within Ceph. Second thing is there's no debating that Ceph is the top choice in our community here. In open infrastructure, this is last year's survey. We've shown that Ceph is growing year by year. And as of last year, 82% of the open infrastructure users reported that they're using Ceph. So it's the top, that's for sure. But that's not what I want to talk about today. The last thing I want to say is that for our community, it's actually we're very happy to be here finally in Seoul. Just before the pandemic, we had organized a big conference here in Seoul, and then that got unfortunately canceled. So it's good closure for most of us. So thank you that we're back. Very briefly, who am I? I'm one of the members of the Ceph Executive Council driving the Ceph project, and I'm also CTO at Klyso, a Ceph solutions provider and support and professional services company. My background's in distributed computing. I worked at CERN, built out the computing grids, discovered the Higgs boson, operated Ceph there at scales for the last decade. And there's some pictures of the early days of Ceph and the early days of big science. And I've always been happy to participate in this community, and I've always been a big fan of Korean food, and I'm very happy to be here presenting about Ceph. So, like I said, I want to talk about why Ceph is the best. But first, I want to talk a bit about what is Ceph, actually. It's a software, right? And let's come back to that plot. We see it so popular, but we don't really talk at our Ceph events and at conferences like this about what makes Ceph unique. We used to talk about this a lot, but why is it so good? Why is it growing always every year? So this is my sort of for newcomers, if you've never used Ceph or heard about it. The basic thing is, you're starting with an IT requirement. Maybe you're building your private cloud. You need block storage and object storage, probably. You're building an AI data lake. You'll need some object storage or some very fast, also local file system. You have your researchers for file system, object storage. Most of the time, you need a mixture. There's different flavors of storage, right? Block, object, and file. You need them all. So you need a kind of unified storage system. With Ceph, the next step is you go and buy some commodity components. You go to Best Buy if you're in the US, you go to Media Market if you're in Europe, or you go to Yongsan Market here in Seoul. You pick up some really good data center quality components, and you put them together. You install Linux, you install Ceph, which we call the Linux of storage, on top, and then you have a workable enterprise quality, very good system. Now you start to get the advantages of Ceph. It's working well. A few months later, you want to add more. It's a very flexible, rebalancing data system. You can just transparently add or remove, elastically manage the storage. And then maybe a few years later, your hardware's expiring. You need to actually replace that hardware. Well, in conventional systems, you have to buy a new appliance, copy the data over. This is a very time-consuming, disruptive operation. In Ceph, you don't have to do this. It's like a cluster, a data storage system is like a living organism that lives forever, and it flows like water between the storages. You keep renewing the cluster forever, and it lives forever. The oldest clusters I operate are 13 years old, at least. Okay. This is a little bit more about what is storage, so what makes Ceph unique. In the olden days, storage, you have this kind of legacy architecture of master, standby, failover. You have IP addresses, virtual IPs that you move around and you fail over pairs. You have multipath. It's like the old way, but still many storage systems are based on this paradigm. Ceph is completely different. The idea is you put intelligence in the client and you use very advanced software to actually manage and distribute the data and keep replicas on different disks, make it reliable. Smart request routing, but in summary, it's magic, okay? And with that magic, we build this unified storage system. In the good old days of the OpenStack conferences and when we used to present stuff, we used to be, we came out of California, the project, and we talk about how awesome that all these components are. So I just want to remind everyone that this is all still awesome. So the Rados layer at the bottom, this is a low-level system, is a debug. Okay? The library accessing is tayback. The object storage part is tayback also. Okay? The block and the file, tayback. The whole thing, tayback. But that's like surface level stuff. What are some of the technologies? This is a really powerful technology. So what makes it actually so powerful? When you're building a distributed store system, some of the very early questions that you have to decide are, how do you make the data store reliably? So how do you store it? And then how do you remember where you stored it? Do you need like a large database or something? And you need to design this for billions of files, tens of thousands of disks or storage components. And there's two like real innovations in Ceph that make this possible. One's called Crush, and one's called PGs, or placement groups. Crush is actually a language. It's like a programming language that lets you describe how you place the data. So it allows Ceph to be aware of your topology. A few talks ago, we heard like data center is the unit of computing. That's right. Ceph has this built in for 20 years now. You can specify where you have data centers, rooms, racks, and you can make rules about where you put the data with replication, with erasure coding, with more than 6 or 7 different erasure coding schemes, whichever you want. And this system is actually very fast. It computes the locations of the objects very quickly, and it's a very small binary blob that gets shared around the cluster. And then together with this, it means that you don't need like a large database to remember where all the objects are. Everything very quickly can work out where the data should be, and it moves things around to keep it, to be able to quickly find it. And so with this, it's like Ceph is exascale. The second question is, how do we replicate the data for reliability? And I just want to point out that there's like 2 ends of the spectrum of how to do this. The old school way, like with RAID, is that you replicate disks, right? So you want to have maybe 3 disks all with the same data. And if a disk fails, you better have a spare empty disk that you can have it copy the data to so that you're not degraded anymore. That's the picture on the left there. Another way that you could do it at the other end of the spectrum is you replicate the objects. So for every object, we just uniquely, for each object, we pick 3 disks at random, and we store them in those 3 disks. That's another, maybe that's a good approach, but let's see, what do they actually mean? With the replicating disk technique, you need empty spare disks around. This is like wasting resources. And also, maybe even more importantly, the recovery is very slow. As devices get larger and larger, now we have more than 20 terabyte spinning disks, much larger NVMEs, the recovery is bottlenecked by the disk throughput and the network throughput of a single device. That's not very good. Now, a problem with the replicating objects technique is that every time that you have 3 devices failing, and this happens all the time in a real production infrastructure, you have data loss. So you cannot couple all devices like that. Okay, so this is why Ceph brought this innovation more than 20 years ago. It's called placement groups. Okay, and Ceph invented this before the other Facebook, other papers came out, and they introduced this topic. But Ceph has had this for a long time. The idea is that you group objects into small groups, and then what it means is that very few of those triple failures actually lose data. In practice, none of them lose data. In all of my time with Ceph, I've never seen data loss on properly managed and configured clusters. So it allows you to not only make a very high available system, but also it means the recovery process proceeds in failure. If you have any component in your cluster failing, all of the other components in the cluster work together to re-replicate the data. So in real life, it doesn't take hours to rebuild after a failure. It takes maybe 1 minute or maybe even 30 seconds. So that's part of the technology, what makes Ceph so special. Now I'll talk about some kind of more engineering operations observations over the years that I've seen where Ceph actually demonstrated its real power. And part of that is how it actually, I think it's better than the components that we make our Ceph clusters out of. It's actively debugging the hardware and the software. we've seen all kinds of network failures, packet corruptions, router line cards doing amazing things, but Ceph is always surviving these because of its very strict checksums and checking the correctness of the data. In our experience, Ceph is detecting problems in the network before the network monitoring observability systems actually detect it themselves. Also, Ceph with the underlying, like with operating system, the libraries, we have many examples where Ceph found very obscure bugs in memory allocations in file systems. Also, one of the more interesting experiences we had was that even the compression libraries that we use, like LZ4, had a very extremely rare but very important data corruption issue with a particular set of input data. It would corrupt the data, and this impacted some real life use cases. Also, with Ceph, we find because it really relies on the promises made by our storage devices. Like if we try to flush the data, if we ask a device to flush the data, we trust that it really has. So we have found all kinds of problems with these kind of issues. And in the Ceph community, we participate in the NVMe standards to do more accurate testing, more strict testing for certifying devices. There's many other examples, but I'll just move on. So Ceph is also better than the others, right? We know it's really popular. We already see that it's used in 82% of the OpenStack users that responded to the survey last year. We keep a public telemetry. We have a dashboard on the Ceph website, and we for those that opt in, we collect how much. Well, if they're using Ceph, how large it all is. Of those public telemetries, there's more than 1.5 exabyte today of Ceph. The reality that we know through other of the non-public clusters, the number is more like 3, maybe even 10 times that number. And these are not like small toy clusters. These are not fake numbers. These are real organizations trusting Ceph with their most important data. And I've moved, in the last 2 years, I moved from academia at CERN to the business world, and now I'm participating more in, competitive processes as a Ceph vendor as well. And I can tell you, Ceph ticks all the boxes when you're building a private infrastructure. It's ticking all the boxes, but it's ticking them for real. Those functionalities, the security, the durability, scalability, it's like real. There's no lies. When you compare it with other open source enterprise quality systems, if you dig deep, you find things in the documentation like you can't add capacity without downtime, or you can't add HA after the fact. You have to design it from the beginning. These are inflexible systems. But Ceph is very different. It's very powerful. Ceph also has some kind of bad vibe about Ceph being slow or not having performance, but this is also not in any way the case. This year, for one of the customers, we built a 1 terabyte per system, a 1 terabyte per second system based on some NVMEs. It was a pretty modest cluster. It's not a massive thing, and this is all publicly viewable on the Ceph.io website. Can Ceph do better? Of course, and that's where it comes to community. And these are more of the advantages of Ceph. Somehow, we also don't talk that much about the advantage of open source anymore. We come to take it for granted, but we have long said a kind of buzzword that Ceph is the Linux of storage. What does that mean? It doesn't mean that it's free and it's everywhere. It means that through all of our diverse environments, you work together and you make the best technology. And that's really what we see with Ceph. It's something that has so many advantages that bring us all to that, like maybe the community, maybe the transparency and security, so you can see what's inside. Maybe it's just because you know that you're not locked into one vendor, things like that. But there's so many advantages of open source that make Ceph better and make it contribute to that such huge uptake that we have. It's also, there's real examples of this. Some of the best ideas in Ceph didn't come from the core team. Here if we're here about OpenStack, we're here about block storage. And it's a very interesting fact that in 2010, the whole idea of block storage on Ceph, that was contributed just by someone anonymous on the mailing list, just contributed the RBD driver. And from there, we had something ready for OpenStack when that whole private cloud revolution took off, and we had the most mature backend for private clouds. There's many more examples of collaboration. There's a word cloud on the left of all of the different organizations that contributed to our most recent release, and I'm sure you can find your company on there as well. We actually formally organize all of the different interests in the Ceph Foundation as well. So there's also, just like there's, as a member of the Linux Foundation, we have a nonprofit organization to collect the resources together and do this maintenance of the Open Ceph project. This Ceph Foundation manages the website, the documentations, also the builds at download.ceph.com, and we just try to collaborate in different ways to promote and improve the Ceph technology. We are always happy to have new members. We're always looking for new, if someone has interest to make Ceph better, please reach out to us, and we can find some good projects to work on together. Also, we are now organizing, or it's all planned, that we just actually finished the agenda. If you would love to visit Switzerland, we'd welcome you to come the first week of December to visit. It's hosted by CERN in Geneva, Switzerland, our large yearly Ceph event called CephLaCon. So please join that if you are able. And with that, thank you. That's the end of my talk.